The topic what we are discussing is bridges. What is a bridge? What is the purpose of a bridge? Yes, unknown values of unknown values of what? Okay. Okay. Listen here. The bridge, electronic circuit, which is used to measure the unknown element of a circuit. Unknown element. There are circuit elements are there, different circuit elements are there. Depending on the requirement, we are going to develop the circuit. We will use different components. Sometimes we are using the unknown values. Based on the unknown values, my circuit is executing efficiently. The circuit is giving the proper outcome. I am keep on adjusting the values of the element. Finally, the output is we are able to generate. Then, based on the output, I am able to check it out. What is the input? What is the circuit element I am using? So, we are going to have one set of circuits called the bridges. Bridges are basically known for measuring the circuit elements, values of the circuit elements. So, as you know that one, x, y, z. If you know x, y, you are able to find out the z value. Okay, in an expression, if we have x, y, z, you know the x and y, there is a position to measure the z value. Similarly, our circuit, it may be n number of elements. Out of n number of elements, one element is unknown element. By adjusting the existing elements, we are able to find out the value of the unknown elements. Already we did this much in the lab also, two experiments we have completed. So, in those two experiments, we were measuring only the resistance. Okay, only the resistance element we are measuring over. But there are so many other features are there, we are able to measure capacitance, inductance, frequency, and minimum. So, bridges are classified. One is DC bridges, other is AC bridges. So bridge in DC bridges basically it is meant for measuring the resistance. AC bridges, as the circuit says, AC elements. There are so many AC elements are there, like the capacitance is for charging and discharging. Correct? So it is meant for AC operations, AC signal. Similarly, inductance is also. Inductance is also for charging. And frequency, as the frequency increases number of cycles, it is AC component only. This is constant. But whenever there is a frequency, is there AC component will go problem. So we are able to measure the AC elements like capacitor, inductor, and also frequency by using the AC bridges. But we are using the DC bridge, we are able to measure the resistance. Okay. So this is the first slide where we are able to segregate or we are going to write a hierarchical chart saying that what is in the bridge, what are the classifications of the bridge, under the each classification, what are the different types of bridges comes into picture. So when it comes to DC bridges, they are purely measuring the resistance. So the type of the bridges are Wheatstone bridge, second one is Kelvin bridge, and the third one is mega ohm bridge. Why we call mega ohm bridges? They are able to measure the higher resistance values. In your Wheatstone bridges and also Kelvin bridges, they are measuring very low resistance values. As we have checked in the laboratory, a low resistance, less than 1 ohm, used to measure in Kelvin bridge. If it is low resistance or ohm resistance values in the range, we are able to measure using the Wheatstone bridge. But I am at very high resistance values, like in the form of the mega ohm. So for that, we don't have a separate bridge called the mega ohm bridge problem. So here I am element. Okay, it's what is that? It will be mega ohm, 5.6 kilo and mega ohm. What's the element we have used? The resistor, the physical component what we have used. We are using 100 kilo ohm, 400 kilo ohm, and 300 kilo ohm. We have used the mega ohm resistance voltage. Up to 1 mega ohm, very little. We are not beyond 1 mega. 100 kilo, 200, 300, up to 1 mega ohm, we are able to, we are setting over there. But not beyond 1 mega, we are having a here. But not to measure the mega ohm resistance values, there is a separate set of circuit, separate set of bridges called the mega ohm bridge will call. Okay, so that is DC part. AC part when you look into, you're able to measure the capacitance, you're able to measure the inductance, you're able to measure the frequency. So inductance, three different types of the bridges are there. Maxwell bridge, Hay bridge, Owen bridge. That is to measure the inductance. Next one is capacitance, sharing bridge, or whichever way you want to spell it. Okay, sharing or string, whichever way you want, you can go for it. Sharing bridge is for capacitance. Frequency, weighing bridge. Frequency you want to measure because I am giving the AC signal. I want to know what is the frequency. I want to measure that one. So very clearly, in AC signal, you are seeing this here, we are able to measure that one. But precise value I want to get. Precise value. How to measure? The main criteria is this is zero deflection. Balanced. The circuits, the bridge should be balanced. If the bridge is balanced, we are going to measure the elements one. The value of the elements. The bridge is not balanced, we are not in a position to measure the elements or the value of the elements. Either resistance, capacitance, or frequency, all are same only. The bridge should be balanced. It should not deflect to positive, it should not deflect to negative, it should be kept at zero. All the four bridges what we are going to discuss, the galvanometer or the meter what we are going to deflection meter what we are going to map, it should point to exactly zero. But if you are using the analog meters, we are not in a position to measure them properly. Better to use the digital meters. So exact zero values we are going to get them. Either positive, negative, you can compensate. Means compensate exactly you can fix it to zero. So once it fixes to zero, measure the value of the component what you are measuring. Let us see one by one. Already we have discussed in the lab. I'll just run through the resistance, then I'll go for the capacitance and inductance. So this is the resistance measuring bridge. Can I take input supply? So 2 volts we are given for the bridge. Actually input VDC or EDC 1 volt. There is a galvanometer which is connected to two different elements. A dimension circuit will be a bridge will be having. The Wheatstone bridge is normally used for the comparison and measurement of the resistances. Resistances up to 1 mega ohm. 1 mega ohm to 1 mega ohm. Less than 1 mega you want, less than 1 ohm you want, you can go for 10 minutes. You want to go for more than 1 mega, you have to go for the mega ohm. Okay, bridge. Here, this is already we have seen. In the lab, what it was, the little bit small change was that this entire line, it was inside here. It was inside. Just push it here. Okay. So this is we are going to give the power supply a low power of 2 volts or 3 volts or 4 volts because the resistance what we are using a small resistance only. We are going to give in terms of the minimum volt system, either 2 or 3 or 4, whichever way because it has to sustain that voltage. So the bridge consists of the 4 resistors R1, R2, R3, Rx. R1, R2, R3, Rx. But in the lab, what we are having R1, R2, Rx, and S is what we have done. Correct? R1, R2, Rx, and your S is one more terminal. But whatever the thing, you are going to have the same bridge configurations here. Here, by varying this particular resistance, left side that is the S value, I am able to find the Rx value. This is S, this is Rx. Rx is unknown. Rx is unknown. So, see there, the positive terminal is connected to the Rx. Positive terminal is connected here. Negative terminal is connected to other ends. What are the resistance? There is no polarities. You can connect it in any way. You can connect it in any ways. So, we are having 4 resistors. They are connected in terms of the bridge. Out of that one is unknown, another one is variable resistance. 2 are fixed resistors, 2 are fixed resistors, 1 is unknown resistors which is supposed to be measured, and the 4th one is variable resistor or adjustable resistor. By adjusting this, you are going to balance the circuit. You are going to balance the circuit. Once you balance the circuit, you will come to know what is the adjustable resistance value, and based on that one, you are able to find out what is the unknown resistance. That is, R1 and R2 is fixed, 3 in my case, which is that. Okay. R1 I am writing. Okay. R2, R3 are fixed. R2 are in this circuit. I am talking with respect to this circuit. R2, R3 are fixed. R1 is variable. R1 is variable. Rx is unknown. So based on the equation, I am able to find out how exactly what is the unknown value of the resistance. So which are arranged in a dimension. R2 and R3 are normally known resistor. R1 is a variable resistance. Rx is the unknown resistance value associated with the transducer's output. So there are two switches they are given, not required, just for the sake they are given over there. Those without the switch also you are able to work them. You can execute them itself. Noted down the circuit. Can we note down? Just note down the circuit, and I think these lights I need to switch off. Why is it resistor? Yeah, see, these are it's like very old book. After when you are having digital meters, you are not having the calibrated. The calibrated. Some up to 90%, 80% they are able to get out. So for that, externally they are connected the resistance such that it's not on the device. Not on the device. Now all the meters are calibrated. 99% of efficiency is going to be there. 99% of efficiency they can achieve that. That's why internally there may be resistance there. Because with the reverse what they are having, they was not having resistance. Now the digital meters what they are having, multimeter, internal resistance will take care. Okay, so you can write this diagram in your examination or IA, or you can write the diagram what we have in the lab. That is also sufficient. Okay. Galvanometer to measure the current between these two terminals B and D is going to be balanced. You want to balance it. A, B, C, D, 4 vertices are there. Okay. So you are going to connect your power supply in between A and C, and you are going to measure the current between B and D. Current will be measured between B and D. Power supply will be given between A and C terminals. No need to write entire theory there on the slide. Just mention 4 resistors R1, R2, R3, Rx. R2 and R3 are fixed resistors, R1 is variable resistance, Rx is unknown resistance. This is R1, R2, R3, Rx. I know from far end you are not able to recognize which is R1, R2, R3, Rx. R1, R2, R3, Rx. R2 and R3 are known. R1 is variable. Rx is unknown. Only this much is sufficient. Yes. Now let us see. Similarly, you know the current also. The current flowing through current flowing through current I1, I2, I3, IX. Current also is there. I1, I2, I3 and IX. Four values are there. If it is parallel, if the resistors are in parallel, whether the current divides or current is same. KVL, KCL, you know. Okay, moving ahead. We have to balance the circuit, balance the bridge. Balance bridge means that the potential between point B and D equal to 0. Potential between point B and D is equal to 0. When the voltage E is applied to the circuit by closing switch S1, okay, that is the theory. To examine the balance bridge condition, we can close the switch S2. If the sensing device reads no current, then the bridge is balanced. If there is some current, then it is unbalanced. If there is some current, it is unbalanced. If the current is 0, then we say it's a balanced circuit. We can balance the bridge by varying the R1 value until G reaches to 0 current. Already it's been discussed. No need to keep writing or wasting the time. You are just say the galvanometer should show 0 current. That is what balanced. How to make it balanced current? Just vary the R1 value. Keep varying the R1 value until your galvanometer shows to 0. Now, this equation also we know that one P by Q is equal to R by Rx by S. Rx can be calculated by P by Q into S. We did that one in the lab, and once we know the P value, Q value, S value, Rx value can be easily identified. Same thing is been given here. Okay, Rx is equal to R1 R3 into R2. Rx is equal to R1 R2 into R1 R3 into R2 is what they have given over there. Here Rx, this is Rx, this is variable. Rx equals R1 R3 divided by R2. Same thing, P by Q into S. P by Q into S is what we have done. We guarantee that the bridge is balanced. The values R1, R2 and R3 are known. Once we know them, we can easily find that one. So voltage V1 is equal to V2, which is equal to I1 R1 is equal to I2 R2. Voltage is same. Okay, when you are supplying the voltage, it's going to be V1 and V2, both are same voltage itself. Once you know the V1, V2 voltage, I1 R1 is equal to I2 R2. I1 is given as E by R2 plus R3. Similarly, I2 is also, I2 is E by R2 plus R3. I1 is E by R1 plus Rx. When you substitute these two in the first equation, you're able to find out what is the R value. Or directly we can substitute the resistance values, you're able to find that. Ratio arms. In bridges, the term ratio arm is used to describe two adjacent resistance values, and the same thing has been given. Example, R2 and R3 and R1 and Rx are the two adjacent values. AC current measurement. There are some bridges arrangements used for measuring the AC current. In these bridges, the inductance and capacitance are going to be used. Till now, DC what we have measured, but if you want to measure the AC, means your input is AC. What I have given in the previous circuit is DC. Here a pure DC I have given. So I am able to measure the DC current and I am able to measure the resistance itself. But if you want to measure the AC currents, only resistance is not sufficient. You are supposed to go for inductance and also capacitance or capacitance. Let us see one by one. And this is measurement of resistance. How you are going to do that one? The same thing has been given. You are able to measure it. AC bridges. where capacitance or inductance are going to be used. Bridges with AC excitation are used to measure the unknown impedances. As far as DC bridges, both null and deflection types exist, with null types being generally reserved for the calibration duties. Generally, what is the purpose means? Whenever you want to calibrate, I told you, repeatedly I was keep on telling, see, the device should be calibrated, the equipment should be calibrated, otherwise you will not get the proper output. See, in our labs, most of the equipments, they are 5 years old, 10 years old, 20 years old. 20 years service it has been given. Some of them we have procured the new one. New equipments also is there. So as we keep on using for many years, the life of that particular equipment is attenuating. It is decreasing. But we will not leave it as it is. We will call the service person. We are going to service that. So they are going to service. As you are doing your vehicles and all, service. Vehicle should be serviced. Okay. Similarly, the equipments what they are using in the lab, they need to be serviced over there so that they are going to get the proper output. That means you are calibrating them. You are going to check what is the input I am giving, what is the output it is getting. If the output with what we are getting is not correct, then we are going to service those equipment such a way that we should get 99.99% accurate results on it. Okay, so it should be calibrated. How to calibrate? Using your galvanometer, you are going to do that. Or using your bridges, you are going to calibrate them itself. So, null type impedance bridge. A typical null type impedance bridge is shown in the figure here. It is null type impedance. Okay, here the null point can be conveniently detected by monitoring the output with a pair of headphone connected. One example he has given. Instead of galvanometer, he has connected the headphone. By connecting the headphone to the two ends, we are able to see to that one whether we are receiving the voice properly or not. Any noise is there. If you are able to get the proper output without any noise, that means the bridge is balanced. The circuit is working properly. If it is noise is being generated due to some unavoidable circumstances, you need to tune them. You're tuning. Example is your radio. You are not tuned it properly. If you put a headphone, you are getting a noise. Tune them properly. What you are doing there? Just you are adjusting the resistance. You are adjusting the resistance value. Whatever you are doing in your FM radios and all, no, previously, or even in our labs also, I'm not in a position to get the waveform properly. I'm not in a position to get the output properly. I need to get 5 volts, but I'm not getting 5 volts. I'm getting 4.5 volts. Assume I'm getting 4.5 volts. I need to set it to 5 volts. If I need to set it to 5 volts in the sense, I should reduce the resistance. Just tune them. So once you tune it, it will see to that one, your output will become 5 volts. Similarly, in your radios or FM radios or whichever devices you are having, you have connected your headphone, you are tuning your frequency you are tuning that. That's frequency measurement also you can call that one. Tune the frequency to the particular value. Once the frequency is being tuned, it is balanced, so you are going to get the proper voice in the headphone itself. So same thing variable. That is why AC measurement. The frequency need to be tuned properly, such a way that when you are going to get the signal from that one. So example is headphone connection to your bridge, and you are able to get the proper outcome over there. So an operational amplifier across the point BD, B and D what we are having is within that we are going to connect the headphone. This is the headphone. Instead of galvanometer, I am connecting the headphone over there. Okay. This is a much cheaper method for null detection than the application of an expensive galvanometer that is required for a DC Wheatstone bridge. DC Wheatstone bridge. So galvanometer is higher, costlier. Instead of that, when you can, what is the cost of the headphone or earphone? You are able to get it for 100 rupees. Correct? No. You are able to get it. So it is there. See, Bluetooth device, it may be costlier. Bluetooth, wireless, it may be costlier. Even that is also earphone or headphone, we'll call that one. But in the market, you're able to get it for even for 30 rupees, 40 rupees, we are able to get the headphones. But it may not last for a long time. I accept that one. But if you want to listen the audio, connect them. It is wear and tear, Kranti. It all depends on how you are going to use them. You have a FM radio or you have a mobile phone. Okay, connect your headphone, hang it. Don't touch that. How many days you want, it will come. But if you keep on plug in, plug out, wear and tear, throw it out, within a day you are going to spoil that one. Even if it is Bluetooth device also, it's same. Correct? No? What is that? Boat, huh? Boat. Okay. Even wear and tear comes into picture. That is also. It all depends on how we are going to use that. Okay. Same circuit. Circuit is same. We have connected the AC. We are connecting the AC here instead of the DC voltage. Chandrakant. The difference here is we have not given the DC input here. We are connecting the AC input. Example is your FM radio. FM radio is a frequency 92.7 FM or 93.5 Disha, 91.1. There are different frequencies. Frequencies we are connected. Tune to that frequency, balance the circuit, immediately you are able to get the result. So many examples are there. So many examples are there where your balancing circuit comes into picture. Your petrol pump. Petrol pump is one of the example. If you are not balancing that circuit, you are not able to pump the petrol properly. Okay, a small variation, it may cost you a lot. Instead of 100 rupees petrol, you may get only 70 rupees petrol itself. Okay, if the bridge is balanced, definitely you are going to get proper outcome. If the bridge is unbalanced, your outcome will be zero. Means it will be abrupt. All four arms are considered as impedance, frequency dependent components. The detector is an AC responding device. This is the detector. The D what we are having, it's a headphone which is connected. Chandana Allah, concentrate Mariva. The D what we are calling, it is similar to your galvanometer. It is a detector. It's going to detect whether the AC component what you are measuring, it's going to verify that one. Whether it is balanced or unbalanced, going to detect that one. Sources, we are having a AC source, AC voltage source with a desired frequency. Okay. We are having four arms, Z1, Z2, Z3, Z4. Same similar to your previous resistor values. Instead of resistance, we'll call them as impedance. Okay. At balanced point, here I1 Z1 should be equal to I2 Z2. If it is balanced, I1 Z1 should be equal to I2 Z2. Similarly, in your previous case also same thing, same procedure we are following. Okay. That is I1 is equal to V by Z1 plus Z3 and I2 is equal to V by Z2 plus Z4. You can measure it. Same current is flowing here. I Z1 plus Z3, same current flowing in this direction. Come here and in this direction. Same current flowing in this right side also. I2 Z2 plus Z4 is going to give. So when you take the equation Z1 Z4 is equal to Z2 Z3 and you're going to have the polar form and also you're going to have the magnitude and also balanced data. Just 1 second, it's not going. So just note down, this is equation you have to note down. Note down the equation for AC. Instead of R1, R2, R3, R4, we are going to have Z1, Z2, Z3, Z4. Z2, Z3 is equal to Z1, Z4. We are going to have the balance, magnitude balance and phase balance. Z1, Z4 is equal to Z2, Z3 is a magnitude balance. Phase also you want to, because we are using a frequency, AC signal we are using. We should also measure the phase. Some of them, phase should be balanced, phase should be synchronized. If the phase is not balanced, positive becomes negative, negative becomes positive, or there is some phase shift comes into picture. You are going to get the unbalanced bridges unbalanced output. So phase also should be balanced, magnitude also should be balanced. Done? Similarly, capacitance measurement, impedance measurement, frequency measurement. Capacitance, impedance, frequency. This is the phase. Angle of 1, theta 1 plus theta 4, which is equal to theta 2 plus theta 3. Moving ahead, let us measure the capacitance. Capacitance measurement. A small change in the circuit. It was similar to your DC circuit bridge, but here input is AC and capacitance has been added to the variable resistance and also unknown resistance. Capacitance has been added to variable resistance and capacitance has been added to unknown resistance also. Only that is the difference. All other operations will be same. Difference is only capacitance has been added. Note down the equation. Unknown capacitance or inductance can be measured by comparing them with the known capacitance or inductance. Whereas the unknown capacitance on the right side, here is the unknown capacitance and we have the known capacitance here. By varying the resistance value, we are able to balance the circuit. A detector is going to detect the zero value. Once it has been detected, then we are able to check it out. What is the resistance? What is the capacitance? Once you know Rx value, then it is able to find the Cx value also. But one more important feature is we have two variable resistances. At the term of R1 also we have variable, term of R3 also we have variable resistance. To satisfy both balance conditions, the bridge must contain two variable elements in its configuration. Two variable elements in its configuration. I'm having a variable resistance, two variable resistance I'm having. This is with respect to capacitance. Similarly, we are going to have the inductance. Same procedure. Their capacitance comes 1 by capacitance. Here it is directly inductance is added. Imaginary part of the inductance is going to be added over there. In the previous case, it is 1 by j omega cx in capacitance. In inductance, this is capacitance I'm talking about. Next slide will be inductance slide will come here. Wherever the capacitor is there, you have to replace with the inductor. See, I'm having an inductor here, I'm having an inductor here. And your Rx value, Rx plus j omega Lx and Rs plus j omega Lx will come, Ls will come. Once you know the first one, the DC bridge, we're able to explain all the three bridges. But you should know how to write the capacitance, how to write the inductance. Inductance comes in series, capacitance is like a parallel one. Okay, 1 by C, 1 by C. Capacitance comes in 1 by C, L will be directly, we are going to put that one. Next one is the frequency measurement, last part of this topic. Measure the frequency. Just your FM radios, TV channels, audio channels, video channels, what the radio channels. We have to measure the frequency. we go for how to measure the frequency further. Vein bridge, it is mainly used for frequency measurement. See there, the difference is we are having R1 with C1 and R3 with parallel with C3. R1 in series with C1, R3 in parallel with C3 I am having over there. This is for measuring the frequency. Measure frequency of the voltage source using series RC in one arm and parallel RC in adjoining arm. Clearly it is mentioned in one arm we are having series capacitor RC, series RC. In one arm we are going to have the parallel RC. So my input is having some voltage and also it's having some frequency. Likit. Whatever the input voltage I am going to have, it's an AC voltage that will be having some frequency. I need to measure that frequency. How to measure them? Just the circuit arms, two arms what we are having, we supposed to replace one arm with the series RC, another arm with the parallel RC we are going to have them. So the equation at balance point Z2 is equal to Z1 Z4 Y3, that is ZY they have given is, they cannot give only R because am I R plus C, am I R plus C, that's why they have taken it as an impedance. Okay, they have not simply taken it as a resistance. Here R1 and C1 both put together is a Z1. R1 and C1 both together is a Z1. Here R2 only resistance is there, you consider this as Z2. Here R3 in parallel with C3, R3 in parallel with C3, that is Z3, and R4 is a Z4. So we are going to see they are not given as Z3 also, they are taken as Y3 because C and R are in parallel, they are taken as Y3. So Z1 is this value, Z2 directly R2, Y3 is 1 by R3 plus J omega C3, and Z4 is R4. Combine them, put them together, you are going to get the equation. Vein bridge is basically used for frequency measurement. Vein bridge basically is for frequency measurement. 4 bridges are there. One is the Wheatstone bridge we have studied, and other one is capacitance bridge, measuring the capacitance. Other one is the inductance measurement. And the third one is vein bridge, which is used for measuring your frequency. So this finishes module number 4. Next week, theory week. Next week, theory week, as far as my knowledge. Tomorrow you will come to know what it is. If it is theory week, next week, 5th module will be completed. I don't know. As far as my knowledge, consult your class teacher. Okay, just now I was discussing with them. They said it's a theory week. If it is theory, we'll continue with theory. If it is practical, we'll go for the practical. Be ready. So this is